Now let's compare this Hadoop to distributed databases. There are a lot of distributed databases, as in not running on a single machine but on multiple machines. First thing is diversity of storage. Now, if we talk about any databases are kind of structured. Okay, when I say structured, like I am discussing both non-relational and relational databases. Okay, there is some sort of structure that you specify, some sort of primary key. Okay, like the DynamoDB is non-relational databases per se, right? But you still specify that partition key, short key, and like how you are, and then you can have random columns in place. Okay, in case of relational, that is more structured in place. Okay, so in case of relational databases, you specify all the columns and then the types, what are the types of those columns. Okay, so diversity of storage. Databases are more structured. Hadoop works on files, so can be written using any data model or encoding. You are not bounded by that. Okay, you can dump anything to files and later figure out how to process it. Don't have to worry about the schema design in case of Hadoop file system. Diversity of processing models. So MapReduce allows to run your own code on large data sets and don't depend on database software. Okay, so what MapReduce is basically a framework, right? And you can write your own code in mapper and reducer. Okay, so you can do all sort of things, whatever is needed. Okay, you don't have that dependency, like how that particular database is working, or like there is some structure which you have to follow, or like if you follow this kind of query pattern or this kind of structure, then your database operations will be more faster. Okay, so you don't have that kind of dependency in case of Hadoop. Okay, so diversity of processing models. You can build tools on top of MapReduce. Whatever it is, let's say Pig, Hive. Okay, all these are built on top of Hadoop to make your life easier, so that you don't have to write those mappers and reducer again and again. Designing for frequent faults. Okay, so in case of MapReduce, what we are doing is like the output of one operation, okay, is saved to the SDFS. Okay, and then it is accessed again. Okay, so if something fails as something fails in stage 2 or something fails in stage 3, I have those outputs stored on my file. Okay, so I don't have to execute that stage 1 and stage 2 again. I can directly start the stage 3 because I will have the output of stage 2 on my file system. Okay, so if task is aborted, it can be retried, and this also enables resource utilization. And in case of in the book Designing Data Intensive Application, this is discussed, like why this is important. Okay, why this is important. It is not always there that we want this feature to ensure there is no hardware failure. Okay, there might be no hardware failure. Okay, but the main idea is, can I preemptively stop this execution. Okay, let's say there is some more priority code and I have limited resources. If more priority jobs comes in, then I want to execute that job first. Okay, if I want to do it, then I have to close this task. So you execute that more priority task, and then once those tasks are done, then you again start this less priority task, and then it can start from wherever it was left off. So that's why we need those fault handling. It is not just for hardware failures, but there is another reason.